This is Darrell presenting Apple's Develop in Swift Fundamentals curriculum, Unit 1, Lesson 2, Constants, Variables, and Data Types. When we create a constant or a variable, we allocate storage for the value in memory, and we associate the name with the assigned value. Constants are defined using the let keyword. Because it's a constant, you cannot change a constant's value once it is created. So in this case, we created a constant name called name. We assigned it the value John, and then we tried to change name to James, and the compiler pointed out our error. Variables are defined using the var keyword. You can assign a new value to a variable. So in this case, we're creating a variable called age. We assigned it the initial value of 29, and then we changed its value to 30, and the compiler accepted that. Here's a more complicated example where we create a constant default score with the value of 100. Then we create two variables using default score's value. So at this point, we have one constant and two variables, all with the value 100. We print out those values, and we get print out two 100s. And then we set player 1 score to be 200. And then we print out player 1 score, and it is 200. We were allowed to set player 1 score to 200 because player 1 score is a variable. When you're planning your app, you want to use constants whenever you can. If the value of something is not going to change during the lifetime of a single execution of the code, then using a constant is a good idea. In this case, we have a route, and the start location and the end location could be implemented as constants, but the car's position should be implemented as a variable because the car's position changes while you're traversing the route. When we're picking names for our constants and variables, there are rules, which are requirements, and then there's best practice. The rules are that you cannot use mathematical symbols, because that would confuse the compiler. You cannot use spaces, and you cannot begin names with a number. You can use Unicode, including emoji symbols, for your names. That can make it easier for writing code when you're writing in a non-English language. However, you can take it too far. Using emoji symbols for a variable name is not a good idea. Names should be clear and descriptive. You want your constant and variable names to be self-documenting. It's obvious what first name means. It is not obvious what n means. We use lower camel case when we have multiple words in a name. So we capitalize the second and later words in the name to make it easy to read, but the first word we keep lowercase. And that's because we use uppercase in the first word for types, and we want types and variable names to appear different at first glance. There are two commenting methods in Swift. You can use a double slash, which starts a comment, and the comment will continue to the end of the line. You can use a slash asterisk, and then the comments will continue until the asterisk slash. These slash asterisk comments can nest inside each other, so it is easy in Swift to comment out the entire contents of a file, even if there are other comments also using slash asterisk inside the same file. Swift uses the term type to mean a grouping of properties and functions. Here we're defining a new type called person. Note that we use upper camel case for our type names in Swift as a best practice. This type has two properties, which are constants, and it has one method, which is like a function, except it's inside the type. In this case, our type is a struct, which is one of the categories of types that you can create. We will cover this in more detail as we go through the course. Here's our person type again, and then we create an instance of person where we pass it by using the person initializer, and we pass it initial values for the two properties. Then we create another instance of person, also using the person initializer, passing it the names of the two properties. Then we call the method on the first person, and then we call our method on the second person. That method, say hello, prints out their name, and you can see in the first instance we printed out the name Jacob Edwards, who was our first person, and the second time we printed out the name of Candace Salinas. Here are the most common built-in types in Swift. We have int, which is an integer, and it represents whole numbers. We have double, which represents a floating point number. We have bool, which is a boolean, which could be true or false. And we have string, which represents text. Swift is a type-safe language. Here we have a player name, which is a constant, which is inferred to be type string. We have player score, which is a variable, which is type integer. And then we have game over, also a variable, which is type boolean. And then what we attempt to take player name, which is a string, and assign it to player score, which is an integer. The compiler does not let us do that. The compiler does not let you assign one type to another type unless you explicitly cast it or convert it in some way. Here's another example. We have whole number, which is of type integer, and we have a number with decimals, which is inferred to be a double. And then we try to take the double and assign it to the integer. Some programming languages would let you do that, and you would truncate the floating point value into an integer. Swift does not. Swift does not allow you to convert a double to an integer automatically. You have to explicitly convert the type as a programmer. That is what Swift calls type safety. Swift is trying to prevent you from making common programming mistakes. When it is not ambiguous, Swift can infer the type. In this case, we have a new constant named city name, and the Swift compiler will infer that the type is string because we have a string literal to the right of the assignment. Likewise, Swift will infer that pi is a double because we have a floating point literal to the right of the assignment operator. When creating our constants or variables, we can use a colon and then specify the type. It's okay to do that. In this case, we're explicitly saying that city name is of type string, even though the compiler would have assumed that anyway. And we're explicitly saying that pi is of type double, even though the compiler would have assumed that anyway. Here's an example where it is necessary. The Swift compiler would have assumed that number is of type integer because we have an integer literal to the right of the assignment operator. However, in our case, we said we're explicitly stating that we want type double, and the compiler will allow us to do this. And then we can print out the number, and you can see it prints it out as a double, including the floating point information. There are three common cases where you need to use type annotation. The first is when you create a constant or a variable before assigning it a value. So in this case, we're creating a constant called first name, and we're saying it's going to be a constant, so once we assign a value to it, we can't change it, and we're saying it's of type string. There's nothing for the compiler to infer the type from because we don't have an equal and then a string literal to the right. So we have to tell the compiler what type it is. And then in this example, later in our code, we would assign a string literal to our first name. Because it's a constant, once we assign a string literal to it, we can't reassign it. We can't give it another string, but we are allowed, when we create a constant, to delay and give it a value later. The second common case where you must specify the type is when you're creating a constant or a variable that could be inferred as two or more different types. For example, here we have middle initial, and we have what is a string literal here with only a single character in it. But we don't want middle initial to be of type string, which is what the compiler would infer. We want middle initial to be of type character. In that case, we have to explicitly state that our type is character. Here's another example where we have a new variable remaining distance, and we have an integer literal to the right of the assignment, and we don't want this to be an integer. We don't even want it to be a double. We want it to be a float, which is another floating point type with less precision than double. The third common case is when we're adding properties to a type definition. Here we're creating a new type called car, and it has three properties: make, model, and year. When we're defining the type, we don't want to put a default value for each of these there here. It would make no sense to have a default value for the make or model or year of a car. We will have to specify those later when we instantiate an actual instance of the car, so we leave them blank. Because we're leaving them blank and not assigning them a value, there's nothing for the compiler to infer a type from, so we must explicitly specify the type. Here we're trying to create a variable named x, but we don't assign it a value, so there's no type that can be inferred, and we're not explicitly stating the type, so as a result the compiler throws an error. Here is our fix where we specify that x is of type integer. The Swift compiler forces us to initialize values before they are accessed. In this case, we define a new variable x, which is of type integer, but we never initialize it, and then we attempt to print out its value. Swift does not do this. This is part of Swift's attempt to prevent you from committing common coding errors. Every possible execution path between defining the variable x and using the variable x must have a place where you specify what x actually is, where you give it a value. You must give it a value before you use it. Here's our fix where we initialize x to a value of 10 before we use it. Long numeric literals can be hard to read. You can put underscores in your numeric literals and they do not change the value. That lets you organize your integers or numbers by thousands, millions, billions, and so forth. If you are following the Apple curriculum, you can open up the Constants and Variables playground and complete the exercises. Keep in mind there are multiple pages in that playground, so make sure to complete all of the pages, not just the front page. This slide deck was created by Apple and is licensed by Apple under the Creative Commons Attribution Non-Commercial Share-alike 4.0 International License.